All right, today we are learning how can I solve system equations by substitution. So before we did it by graphing,
Right.
and this time if our graph doesn't like line up nicely, as you can see in kind of this example down here, it doesn't actually cross at a nice like intersection of our grid, we're going to have to use substitution to figure it out.
Right. And I always like to sometimes throw in the who uses this. If you're going to be a zookeeper someday,
Maybe.
you may use algebraic methods to solve systems of linear equations that model mixtures of animals' foods.
Wow.
Isn't that kind of cool? So now if I scroll down, just like Miss Boyd just said, look at that graph carefully.
Yeah.
You cannot find the solution by graphing. It's just not easy. So if you don't have a graphing calculator to use right now and you can't solve graphically like that, then we're going to teach you how to use substitution.
Okay.
As a reminder, when you find a solution to a system of equations, you are finding an ordered pair or pairs.
So an x value or y value.
You got it. So now we're going to go to the next page.
All right.
And we already have an example right away that we're going to start with. So we're going to use substitution. And I always like to follow steps. As you can see, there's steps right there. So step one means isolate one variable, really in either equation. So look up there. Isn't something already isolated?
It's already done. We already have a y by itself.
Perfect. So step one is already done.
Done.
So maybe what we should do is next to step one, maybe we should write what it is so they know what we're talking about. It's y equals 2x minus 1.
All right.
There we go. Step two, you're going to substitute the answer in step one into the other.
Part.
Yeah.
See how it equals y? I'm going to plug it in now for where the y is.
Right. We might need to go below because there's not a lot of room.
So I'm going to have 3x plus 2, and make sure you put parentheses, whatever you're plugging in, 2x minus 1.
Right.
Equals 26.
Now let's circle up there where we got that in case they're really confused right now.
So I just took this second equation.
Right there.
And I rewrote it down here.
There we go.
And I substituted this in because it equals y, so I can plug it in for y, which I did down here.
Good. So now we're going to solve that, and I wonder if you need a little more room. Should I scroll down a little bit here? How's that? There we go.
So now I need to do the distributive property.
Right.
So I'm going to bring this down. I got 4x minus 2, and now I'm going to bring this down. I have my 3x plus it, and now I need to bring this down, equals 26.
Perfect.
Now it's just basic algebra, combine our like terms. So I have 7x minus 2 equals 26.
Yep.
Change my pen here, add 2, and I get 7x equals 28.
Yes.
And we know that x then equals 4.
Right, because you divide both sides by 7. So that's our step 2. So maybe let's write step 2 so we know that they can follow these steps. So that right there is step 2. Now step 3 says substitute the x value, which we found, into one of the original equations. Okay. So if we go back up, what do you think is the easiest one to use, Miss Boyd?
If we want to find what our y is, since y is here, let's plug it in this original one.
Right. So I'm going to scroll down for you. So we have step 3. Let's label that.
Step 3.
And it's going to be y equals 2x minus 1. Let's rewrite that.
Awesome.
Now we're going to substitute that x into there. You got it.
Wonderful. So we get y equals 2 times 4 minus 1. We'll just clean that up. 8 minus 1. We get y equals 7.
And we now have an x and we have a y.
So our final answer is going to be,
we're going to write as an ordered pair.
4, 7.
And let's put a big circle, box, highlight, whatever you want to do around that. That is the solution to this system of equations.
So what that means is if we plug in a 4 for x, we'll always get 7 for our y. So if we go up real quick. Oh, too far. Sorry. If we go up and you see right up here, if we plug in our 4 for x and our 7 for y, we will get 26.
Exactly. So you can always check your answer that way. I like that. All right, so I think that's it for that page. I kind of took it all up. So example 2, I'm wondering.
This one's a little tricky.
Yeah, we probably should. Yeah, we need to go through this. So let's start step 1.
We want to isolate.
Which one do you think's easier?
I'm going to do this one for step 1.
I agree.
Because I just need to get rid of this negative.
That's it.
And it's like a -1 right now. So I just divide everything by -1.
And then we
So in order to get that, I now have, well, a 2 divided by -1 is a negative 2x.
Plus 2, right? Negative divided by a negative.
Equals my y.
There we go. And I don't like to write it that way. So can we change it so it's y equals?
Y equals
negative 2x plus 2. That's step 1.
Just highlight that. So
I like it.
That's our final equation when we changed it.
Right. So now step 2, we have to substitute step 1 into the other equation. So
I'm taking this.
Yep.
And I'm plugging it in for the y right here.
Right there. Perfect.
So I'm going to rewrite that down here.
Yep. Good.
So step 2.
Yep. I like it.
I have 5x plus 6. And instead of y, now I'm writing negative 2x plus 2
equals negative 9.
Negative 9.
And now I'm going to scroll down so you have some room there.
Wonderful.
There we go.
All right. I have my 5x.
Yes.
Plus. Well, this is actually going to change it to a negative 12x. So I'm going to quick erase that.
Okay.
And make it a minus 12x.
But what if someone didn't want to do that and they had a plus? Could they have then done plus negative 12? Okay.
Same thing. And then a 6 times a 2 is a plus 12.
Good.
Equals negative 9.
Right.
Again, clean it up. So I've got a negative 7x plus 12 equals negative 9.
You got it.
Subtract my 12. So I get negative 7x equals negative 21. Divide by my negative 7.
Yep.
And I get 3.
You got it.
Divided by a negative
is a positive. So we have one of our answers.
One of our answers.
That's step 2. And remember now, step 3, I'm gonna scroll up. We're gonna substitute it back into one of the original equations.
And I'm going to plug it into this one.
Right.
Because we already have y solved.
And you know what? I'm really glad you said that because I know the directions say original. Well, that is the original,
We just
changed
it to get y by
right.
itself.
So should I scroll down so you can rewrite that?
Negative 2x plus 12.
Yeah. So step 3.
Y equals negative 2x plus 12.
Right.
Here's step 3. So now, again, like we said, we're going to take this and plug it in for our x.
Right.
So now I have y equals, negative 2.
Times 3.
Times 3.
Plus
12.
Right.
So I get y equals negative 6 plus 12. So y equals 6. So there's our other one.
Exactly.
And now, for our final, we have to put it in an ordered pair. So 3, 6. And that's our final answer.
You got it. Okay, so let's looking at this, I think in step 3, Miss Boyd, we wrote down the wrong equation. So I think we should erase.
Yeah, it was supposed to be a 2.
Yeah, so let's do that.
And I accidentally put 12.
There we go.
So let's redo
You
this.
all are probably thinking, what are they thinking? They are just some crazy.
All right, so this was supposed to be a 2.
There we go.
So when I bring this 2 down, and I bring this 2 down, so I really get a negative 4.
That looks much better. So now our final answer is yes. 3, negative 4. Good. All right, we are good.
To check that, just put it back in those equations and see if it works. If it does, then you're good.
You would have found it if we didn't, right? All right, next page, and we are moving on to, I'm wondering if example 3, what do you think?
Do that in class.
Because then really this could be a nice quick video.
I like it.
So let's go to the next page. And look at that.
There are your
2 questions. We will see you tomorrow.
Bye.